Well, hello there, it's Monday. The other day, had a radio through the post, which is the Maxon CM10. I think they were about 8 years ago, 6 years ago, something like that. And they did the CM70. We've got a CM70 new in a box, so I really ought to try and get on with that this week. And this has been sent, not as a repair, but actually as a free gift, which is very, very kind of Kevin. So we've had a bit of an email backwards and forwards. He says, "Hi Richard, please find enclosed the Maxon CM10 as promised. Bought it second hand off eBay 4 years ago, as it was received with no box or manual." And then he says how to turn the radio onto different bands, and and a link for the instruction book, which we actually do already have on file. So very, very kind of Kevin, and thank you very much indeed. If you're listening, as I wander off and look at my printouts, I do have a circuit diagram, because Maxon did put it in the instruction manual, and we've got block diagram and we've got a layout, so we might be able to colour some of those in if I can find the coloured highlighters, if might not as well. And then I've also got printed off that manual the different modes for the different multi-norms that the radio does. Now, I spent a very long time in my business radio career doing Maxon two-way radios, and when they first came into this country with their crystal controlled Apex range, they did leave something to be desired. But when the synthesized PM150 came out, it was a totally different ball game, and the quality kept on going. Well, I did all the training courses offered to me, and at one of the training courses I realised they were blowing their own trumpet, and they were saying we actually manufacture 80, I think it was 83% of the world's CB radios, not just Britain's or Europe's or just America's, but the world's CB radios. And of course they did their own Maxcom range, didn't they? But a lot of the Midland models, Colt models, Cobra models, the Comtel, not Comtel, Comtron models, and the list went on with. Did I mention Cobra somewhere in there? You know, I'm not saying all those suppliers did solely Maxon innards, but Maxon was certainly there. So they were never. I never felt Maxon were the bee's knees of anything. But they were certainly above average and very reliable. Well, they were once the crystal controlled business radios had gone. I wouldn't say much about those. But of course we did one recently, didn't we? We did an old Maxon Apex on UHF, one of the business radio handhelds, and that's now in our local 77's ham repeater. So, what's he sent us? So he sent us the radio. He sent us a useful box we can send something else in. He sent us the factory original microphone. And he's even sent the mounting bracket. So, you know, really, really good to get something in such a nice state. And I've got to try my bestest. How about that for a childish phrase? To not lose the bracket or the side screws. Or are they called thumb screws, or are they something you get in dodgy prisons? So we'll connect this up to power. Someone suggested that we do a before and after on-the-air video, and I think we'll do one as a one-off at some point, because it's pretty pointless showing a crummy radio in operation. But whatever floats your boat. Anyway, it won't be this one. We'll find a much worse candidate. I would think this is pretty well spot on, to be honest. But like a lot of sets, if it hasn't been touched, it may well be low on the deviation. It may well be low on transmit power for the usual legal reasons. Where is the connector? There we are. Yes, somebody said yes, it's getting frayed at the end. Well, it still works, so Mr Chippie doesn't have to reconnect it. Right, so we'll switch the power supply on. We'll switch the radio on. And it's flashing 7 at me, and then it went to channel 30. So what is 7? 7 is the UK. So it's 40 UK and 40 FM. So to change the band, turn the radio off, press and hold the up key and then turn the radio on. Then select the frequency band when it's blinking with the up and down button. Press and hold the down button to confirm. Oh, you can do, the other thing is, which I will just read out, is master reset. That will put it to CE frequency band. It says turn off the radio, switch it on, holding the down button. The CE frequency band of 06 will blink on the display for 3 seconds. That's a master reset, because sometimes, as we would say in the UK, things can get their knickers in a twist, and you can end up with all kinds of strange malfunctions which can be simply reset with a factory reset. So we'll see how this goes. May as well open it up at this stage, because we're going to open it up anyway. And I think this and the CM10 were the last two Maxon sets. And it's made in the Thailand factory, not in the Korean factory, which is interesting. It's got screws at the back. So it's not a pluggable speaker, so I'll switch the soldering iron on ready. I don't know whether we've seen this board before. It's looking down here at the what it says on the board. It says SCM10S, which is what this is. It also says 501 and 932. So are they other models? So we've got a fiberglass board, so we've moved away from the SRBP boards. Synthetic resin bonded paper, which are the brown ones that you had in a bygone era, those type of boards, which tend to be single-sided because they don't tend to be reliable when they're double-sided. Right, we'll unsolder that. Now I'm expecting, probably because of my Maxon training, for this to work really well, and I'd be disappointed if it didn't. So we are looking at a stage where we've got, it looks to me like, without looking at the circuit diagram, we're going to have the VCO there, we're going to have a couple of transmit coils there, transmitter final is there, and then we're going to have the receive here, and it's got AM because there's a modulation transformer, but we won't be doing anything with that. This is, we'll be tuning this as a UK UK only set, because that's all we're interested in doing. What else have we got? We've got the master oscillator crystal there, and that looks like the FM detector, but I could be totally lying, because you know what, that could be the FM detector. It's got a crystal filter in the IF. Ah, we've got a problem. We have a problem. This capacitor is bulging. I'll just see if I can zoom in so you can see that. These are the visual inspections that you need to do when you're servicing stuff like this. you see that has a bulge in it. So it's either already knackered, that's a great word, or it's about to be. So we need to change that before proceeding or even testing the radio, because it's pointless. So we'll switch it off. Now, depending where that is on the circuit, I'll just put the other glasses on. It looks to be capacitor 213. So if we look at the circuit diagram for capacitor 213, this is so small. No, I really just can't see that. So I don't think we need to worry. We'll simply replace it regardless of where it is in the circuit. But it's round the power input and audio amplifier stage. So we'll get that unsoldered immediately. Okay, so we've got that out, and let's have a look what it is. It's 1000 microfarads at 16 volts. For that to be like that, it's going to have had more than 16 volts applied to it. So somebody's overvolted the radio at some time, and it may have been carrying on working, but it's not going to be perfect by some long way. Now, I'll also point out that most capacitors show the negative lead. I'll just bring that out a bit, it's a bit close. Indicated the negative, and the board indicates the positive, so you have to be aware of that. What's the shaded bit on the board is the positive, and what's the shaded bit on the capacitor is the negative. How to get capacitors the wrong way around. So we'll get an Esr meter out. It may still work, it may not, but it's certainly not long for this world. So let's just have a look. So it's 490 microfarads, and it should be 1000. So you know, yeah, it's. I think it shot some of its load there. So we'll get a replacement capacitor in there. In fact, we'll test a new one. This is 105 degree rated, which isn't necessary. The old one was 85, which is more standard. You don't have to be doing that. It's not in a hot area, but we kind of buy them all 105 degree, to be honest. And these leads want a bit cleaning, they're a bit tarnished, and that could lead to dry joints further down the line. $1080 is a bit nearer where you'd expect. So negative, not to the stripy zone. This is a plated through board, and it does need desoldering very carefully, because you could end up with breaking away the plating. So I'm going to power this up, which I have just done, and then I'm going to check with the meter. We've actually got power to this side of the board because it receives its power from the other side of the board, from the component side. It seems to be constantly 6.8 because we've no idea what it's supposed to be. I need an electron microscope to read that circuit diagram. Right, so we've done the obvious, which is change that. Plug the mic in. It's a 4-pin mic. And I'm glad it doesn't have any of those up-down things to get you confused. How many of you noticed that, you know, certainly in Britain, up would normally be on the right. If you got two push buttons, one up for one down, and down would be on the left. That would be normal. But I noticed all the Chinese things we buy, it's the other way around, which is quite confusing. Right, we'll select picture in picture. And I'll put the radio on channel 20, centre of the band. I've no doubt if we press AM FM it goes to CPT and then back, but we'll see what happens. I'll tell you which one's which. Yeah, we're on UK band because, believe it or not, it's spot on frequency. If I press AM FM and it puts a dot on there, it becomes 27225, which is what we'd expect. We're on channel 22, aren't we? And then back. Yeah. So let's see what power we're doing. So full scale deflection would be 3 watts, and it's going banged over, so it's more than 3 watts. That's our 5 watt point, so that should be 4. It's about 3.2, something like that. See if any of these presets are actually labelled. I think the best thing to do, I'm going to look at the circuit on the computer screen where it might be easier than looking at the printout, and I'll see if I can come to a conclusion as to what's what before just messing about. It doesn't have a meter on the radio, so we haven't got that, but we have got 1, 2, 3, 4, 5 presets. So yeah, I think we need to just clarify. So I'll pause the video while I do that. Okay, so one of the reasons is more controls than you think. It's got preset squelch somewhere on there. So where's that? Ah, it's got a click position, which there's nothing mentioned about that. So that is preset squelch. That's typical Maxon to have a feature that I don't even tell you about. So while I was at it, I looked up that capacitor 213 that we changed, and it's part of the audio output. I've brought the circuit diagram back. So 213 is there. Let's just see if we can actually zoom in. So it feeds the AM modulator, you know, it's the entire output of the amplifier into the AM modulator, and in receive it's the output. So if the radio is being used at high volume, or whether it's been overvolted, that could be the reason why it was in the state it was. But it was certainly going to be very poor audio had we run the set. And it doesn't pay to, you know, people say, oh, why don't you try it as it was? Because it could damage the radio, that's why. So we don't run things under fault condition. So hopefully I've worked out some of the tune-up procedure, and I've worked out what most of those presets do with any luck. So going back into transmit, I've got a sneaking suspicion, but I can be wrong, that there is a power control, and it's RV1, which is this one here. So we'll key up. And it's at full power, so that's fine. We just need to make sure that these are peaked. That is definitely peaked. And it's dropping off and off and off as it gets warmer, which is normal enough. I'll just check what our input voltage is, because I'm on the power supply which has analog meters, and although it says somewhere around about 13 volts, you can never be sure, so we'll just put this meter on it. 13.7, that's absolutely fine. I hate to tune it up at too low or too high a voltage. Now I don't like the look of that coil, and that's something we're going to look at on the spectrum analyzer, because I don't like the way it's been twazzled. I don't know whether the coil stretch has been in this radio. If we get the light on that back coil, that doesn't kind of look right to me, and that could be a reason that we've got lower power than I would expect. It's not out of tolerance low, I will add that. Just wait for the spectrum analyzer to boot up, and it's just loosely coupled. So we'll put in the centre frequency of 27,9,125 megs. We'll key up. I need it a bit more of a pickup wire than that. Yeah, I think what we'll do, we'll go over to the spectrum analyzer screen, because I'll take that off. It's going to be a bit crummy. If I key up, there's our 27 megs. That's 27,205 in the middle. And if I move this, we've got second harmonic 50.01705. Absolutely colossal. So I just wonder if what if we can do picture in picture the other way around? No, oh no, we can't. No, I know we can't. Okay, so if I push that coil inwards, I think that's the 54 meg trap. What I want to do is to reduce that to an absolute minimum. So I'll just pause the video and then we'll come back to that screen. This has been tweaked up by the by the coil twaggler. Right, so if we now go back to that, what I've found is an optimum adjustment of the coil that's been fiddled with, which is actually genuine, is really most of the 27 meg signal, and I've actually found that the 50 odd meg trap is this coil here, which had also been messed with. So now if I key up, you'll see we've got all the signal on 27 megs, and if I go around that, we've got nothing up there, and we've got nothing down there. So we now have 3.2 watts on 27.79125 instead of that's still the same kind of power, but quarter of it going out on 54 megs. So there you go, another set which has been now untwiddled, and there you go. You have to have these pieces of kit, don't you? So we'll take that off, and we'll carry on with the normal tune-up. I'll turn the spectrum analyzer off because it has a fan in it and it's noisy. Right, so we'll look at deviation, and as usual we'll use our little Korg thingy-my-flop. Now the other day I made a mistake and altered the note this is on. That's the one. It's B flat. And our deviation is about 0.9 with that. Oh, I've not got the camera on there. I'll just rectify that. So there we have about 1 kilohertz. We'll give it the whistle test. Wallow. Yeah, you can get it to do. You can get it to do 2. So we'll just pop that up a bit. So that is. I want to turn the thing back on. I've got it over the power lead. So deviation is this one here, 401. Wallow. 1, 2. That seems a bit more sensible. And for those of you who are going to be in Europe are using AM, if it's set to a country that does AM, then the AM modulation control is RV201. Which one's that? Yeah, RV201 is the left-hand one of those. We're not touching it because we're not doing AM. So, so that's covered that. That's covered transmit. We'll just show you that it's on frequency. It should be 27.79125. It's 27.79126. I mean, that's spot on, isn't it? But if you did need to adjust it, it's the red trimmer just there. It's not often we have a set that doesn't need anything doing, so well done, stability. So we'll look at receive now. So we want 27.79125 on the signal generator. So we'll just dial that in. We'll plug a speaker into the extension speaker socket or we won't hear anything. There we go. We'll make sure the squelch is at minimum. But at the same time, I'll make sure that it's not in its auto position, which we learned about. So first thing we'll do is I will put the camera 2 onto the oscilloscope, and we'll look at the recovered audio. I'm going to set the detector, and it's a bit ambiguous in my mind as to whether it's that one or that one. One's going to be the AM detector. I think it's that one, but I could be wrong. It's that one. Oh, it's miles out. I bet that sounded really garbled. So that's now peaked, as you can see that. We've got an S9 signal, which is 100 microvolts in the UK for CBS9. Right. Oh, it must have sounded awful. So this is now 0.3 of a microvolt. So we'll move up to the Synad meter. And we'll just see whether we can get anything more out of it, because that really is very good. That's off my clock. That's as far as we go. 0.06 of a microvolt. So we'll just bring it up a bit to the S4. I think this is the most sensitive receiver I've ever seen. So it looks to me to be L3. Yeah, L3. L4. L102. L103. And that's it. I'm very careful to just touch that. Yeah, I think it's the AM one. Yeah, so we weren't going to. I think we've moved it a micro bit of something. So let's look at what that reads. I'll need to fetch my notebook back, but I'll enter it on here so that I don't have to stop the video. So 20. Tell you what, we won't do it on that page. I printed out the specification page somewhere. So we'll do 20 dB. Can't even do a 0 Synad. 12 dB Synad and 10 dB Synad. So for 20, just get that on there. It's about 20. It's 0.57. Normally they're over 1 microvolt. Now it says on here that we should be getting. Actually, it says 0.5 for 20 dB, which is about where it is. Right. I want to believe that. So let's look at 12 dB, which is the industry standard. Change scales. It's 0.19 microvolts for 12 decibel Synad. For 10 dB, it's 0.15 microvolts. Now, who'd have thought that? I mean, at the end of the day, this is a boring looking workaday CB radio, pretty featureless, and it's got the best receive sensitivity I've ever seen. Yeah, right. I wonder if the CM10 uses the same board. We'll find that out in a few days' time when I dig out the CM10. I've got to try and fit repairs in between our own sets, you know, otherwise there'd be customers jumping up and down. Although we do have a 28-day turnaround, so I don't think there's going to be any jumping up and down. Right, we better look at squelch. After all that, what I'll do, I'll move the camera down to the attenuator control so you can see what I'm actually doing. There's the attenuator controls. Let's move those wires out of the way. That's where we're loosely picking up the spectrum analyzer. So this is parked at 0.3 of a microvolt, and this at 0. That's where we kind of start. So what we do, I'll do this the other way round. I'll set the squelch on the radio to full. So if I move this down a bit, this other camera, so that's the squelch control, so that's now at full. What I want to do is I want the squelch to come in at about 100 microvolts. So that's 1 microvolt, 3 microvolts, 10 microvolts, 30 microvolts, 100 microvolts. I want the squelch to be now open. So where does it come in? It comes on at 300 microvolts, so it's not too scary. So I reckon, and I'm competing with the radio as the background music system has gone over to radio. I reckon what? Presets, normal squelch is RV2. So we reckon it's that one. Normal squelch. It is. Carefully adjust that. That's RV2. So open. I just want it to be just open. There. So now 30 microvolts, it doesn't open. 100 microvolts it opens. That's exactly where I want full squelch. So what we're now going to do is to turn the signal generator off. So that's now off. There's a warning light to tell me it's off, and I've parked it again at 0.3 of a microvolt. So I'm going to turn the squelch down on the radio to threshold. And now we'll see when it comes in. So switch the signal generator on, and it's coming straight away, which is excellent. So we'll do the fine tuning, and the squelch drops out at 0.14 of a microvolt, and it comes in at 0.19 of a microvolt. 0.19, 0.14. Wow, that's going to be Scratchy Corner. Is going to be loud and clear. It's going to be hi-fi Scratchy Corner at this rate. So let's see where the preset squelch is, because that doesn't need to be sensitive as that. Otherwise, it would be pointless having it. Really, you want preset squelch to work in town. So really, I want it to be about 3 microvolts. So let's see when it comes in. So we're now at 0.3. We're at 1. We're at 3. That's 10. So we're now with the fine tuner, we'll see where it really is. So it's coming in at 4.7 microvolts, and it's leaving us at 2 microvolts. So I think that range is okay, so we're not going to adjust it. Because you know what it's like, you drive through town, you've got people with Wi-Fi interfering, you've got petrol stations interfering, so you don't want it too sensitive, otherwise you could use the manual squelch. So if we did need to adjust the preset squelch, I'm not going to say auto squelch, because it isn't auto at all, it's preset. In that case it's RV3, which is the one in the naughty corner down there. So that's something we haven't had to adjust, which is nice. So there we have it. That is now working very nicely, thank you very much. But going back to when we were setting that transmitter up, you'd had the coil stretcher in there. It wasn't doing any more power for it at 3.2 watts. Remember when I say 3.2 watts on this Marconi tester, if you put that on a CB type power meter, it probably reads 4.5, 5, I don't know. I look at these things on eBay. I've bought sets off eBay, and the vendors shown them into a power meter doing 6 watts. I get them back here, they're doing 2. You know, because this is what power meters can be like. But this one's is selective, and it's selective to the band we've got it set to. You saw with the spectrum analyzer that a lot of the power was actually out on 54 megs as this radio came. So I think it was doing, out of its 3.2 watts, I would say that 2 watts of it was on the 27 meg frequency and the rest of it was elsewhere. So this would have been poor range. But on the face of it, it looks like it's doing the power. Now I've got the same, exactly the same power with 3.2 watts when the set's hot on this test set, and you know 3.1 of it is actually going on 27 megs, and that's what we're looking for. And that's what having these type of instruments is about. It's not just tweaking it until you see maximum power, because the power isn't always there on 27 megs as we keep seeing when I apply this. Right, so we'll button this one up and we'll put it on the aerial, and of course there won't be anybody on, will there? Because there never is. Just going back into recorders, I put this back together. Remember we changed the capacitor there, which I've said was turned out to be part of the audio amplifier, a very important part of the audio amplifier. As I put this lid back on, which is that way on, look how it's shot its innards out. That's where your other 500 microfarads has gone. It's gone down the inside of the lid. I'm only sorry that the kind gentleman who passed this on to me has never heard this working as it should have done. So I'm going to be looking forward to doing our Scratchy Corner test, and I'm quite sure it's going to make the course very well. What's it? Well, no, Roger. Well, we didn't expect that, did we? See if anything's on CPT band. That's channel 9, that one. One on a Roger. Back to UK. Well, I'll leave it on its. I'll leave it on for a bit, and it can be chuntering to itself. It's nice to have the bracket because we can actually prop it up on there when we do the on-the-air test instead of a screwdriver or a remote control or whatever we happen to have to hand that particular moment. So thanks very much once again, Kevin. That was very kind of you. I'm sorry you didn't hear it work as well as it was capable of doing. And we'll do the on-the-air test later on today. Thank you for watching.